So let's start the questions. First question of the exercise is find the time required for a 50 Hz alternating current to change its value from 0 to the RMS value. So the first question, what do we have? We have frequency equal to 50 Hz. Then current, we know that it is given by I naught sine omega t, where I naught is the peak value and I naught is equal to the RMS value is equal to I naught over root 2. So we need to find the RMS value, so therefore I naught over root 2 equal to I naught. At the place of this I am using RMS value, so I naught sine omega t. So we will have 1 over root 2 equal to sine omega t. We know that 1 over root 2 is when sine is pi by 4. Sine is 45 degrees. So omega t is equal to pi by 4. Now t will be equal to pi over 4 omega. Omega is now omega is 2 pi f. So t will be pi over 8 pi into frequency, which is 50. Pi will get cancelled. So what we will have, 1 over 8 into 50. So time period will come out to be 0.0025 seconds or 2.5 milliseconds. Again, remember, we needed to find RMS value. So at the place of I, we can use IRMS equal to I naught sine omega t for this question, okay? And IRMS is this much. So at the place of IRMS we put I naught over root 2. In question 2, the household supply for electricity is 220 volt. This is the RMS value and 50 Hz. We need to find peak voltage and least possible time in which the voltage can change from RMS value to 0. So this is the second one. So RMS value of voltage is 220 volt. Frequency is 50 Hz. So first of all, we know that RMS value is peak value over root 2. So peak value will be RMS value into root 2. So it will be 220 root 2 volt or 220 into 1.414. So it will be around 311.08 volt. So approximately E naught or the peak value will be 311 volt. So when you have when you say that the voltage at your house is 220 volt, it means the RMS voltage is 220 volt, but the maximum value it can go up to is plus minus 311 volt approximately. Now this was the first part. The second part is time taken for the current to reach the peak value, and it will be equal to, we need to find time taken to reach 0 value from the RMS value. It will be equal to time taken for the current to reach the peak value. These two time periods will be same. So we know that RMS value is I naught over 2, and also I is I naught sine omega t, or IRMS for this part I naught sine omega t. So by these two equations we will have I naught over root 2 equal to I naught sine omega t. So from here omega t will come out to be pi by 4, just like we did in the previous question. So T will be pi over 4 omega, which will be pi over 4 into 2 pi f, or 1 over 400. So time period will be 2.5 milliseconds. In the third question, bulb rated 60 watt at 220 volt is connected across household supply by alternating voltage of 220 volt. We need to calculate maximum instantaneous current through the filament. Third one, power is 60 watt, voltage is 220 volt. Now resistance can be found out using this formula, because power is equal to V square over R. So it will be 220 into 220 over 60. So resistance will come out to be 806.67 ohms. Now V0 will be root 2 into V RMS. So it will be 1.414 into 220. So it will be 311.08. So I0 will be V0 over R. So 311.08 over 806.67. So it will give us approximately 0.39 ampere. So I0 will be approximately 0.39 ampere. In the fourth question, an electric bulb is designed to operate at 12 volt DC. If this bulb is connected to AC source and gives normal brightness, what would be the peak voltage of the source? So fourth question, voltage is given. Now we know that for heat, I square RT or I square RT RMS value are same. So V square over R will be same as V square RMS over R. So V square will be V0 over 2. So V0 square will be 2V square. So V0 square will be 2 into 12 square. So V0 will be root 2 into 144. So V0 will be approximately 17 volt. So what we have done is that in the case of energy or heat, I and RMS value are same. Average value and RMS value are same, or instantaneous value or RMS value are same. So using that we did this. Again, this was heat, time got cancelled. Okay, so we knew that Vrms square is equal to V square, and it is equal to V0 square over 2. Now in question 5, peak power consumed by resistive coil is 80 watt. Find energy consumed by coil in 100 seconds, which is many times larger than the time period of the source. So this is the fifth one. P0 is 80 watt. Peak value is given. So RMS will be P0 over T. In power, RMS value is peak value over 2. So it will be 80 by 2 or 40 watt. So energy will be PRMS into time, so it will be 40 into 100, 4000 joule. So energy will be 4 kilojoule or 4000 joule. In question 6, the dielectric strength of air is given. A parallel plate air capacitor has area and plate separation 0.1 mm. We need to find maximum RMS voltage of an AC source which can be safely connected to this capacitor. So this is the sixth one. The electric field is 3 into 10 to the power 6 volt per meter. Area is 20 centimeters square. D is 0.1 mm. We know that potential difference can be calculated by E into D. So 3 into 10 to the power 6 into 0.1 into 10 to the power minus 3 meter. So voltage will be 300 volt. Now max RMS voltage will be V0 over root 2 or 300 over root 2, 212 volt. So the maximum RMS voltage will be 212 volt. In question 7, the current in discharging LR circuit is given. We need to calculate RMS current for the period t equal to 0 to t equal to tau. So this is the seventh one. Current is given like this. Now RMS value can be found out like this. Squaring, averaging and integrating. So let's put all the constant terms outside. Integrating from 0 to tau as given or as asked. So after integration we will have tau by t, tau by 2, and this from 0 to tau. So once you put the values, you will obtain I0 square over tau by t 2 e to the power minus 2 minus 1. Upper limit minus lower limit. Upper limit minus lower limit. Now let's take the square root of this average. So it will give us RMS value. So root I0 square over 2, 1 by e square minus 1. So I0 by e square minus 1 over 2. So this will be the RMS value. In question 8, a capacitor of capacitance 10 microfarad is connected to oscillator giving some output voltage. We need to find peak current in the circuit for omega equal to 10 per second, 100 per second and 500 per second and 1000 per second. So this is the 8th one. What do we have? We have C equal to 10 microfarad. Capacitance is given 10 into 10 to the power minus 6 farad or 10 to the power minus 5 farad. Then voltage is 10 volt. V0 is 10 sin omega t. First, current. So current can be found out by V0 over XC. So 10 over x is 1 over omega c, 10 over 1 over 10 into 10 to the power minus 5, which will give us 1 into 10 to the power minus 3 ampere. B part. Now omega is 100 per second. So I naught equal to E naught over 1 over omega c, 10, 1 over 100, 10 to the power minus 5, 1 into 10 to the power minus 2 ampere, when omega is 500 per second. So 10 over 1 500 into 10 to the power minus 5, so it will give us 5 into 10 to the power minus 2 ampere, when omega is 1000 per second. Here omega was 10. One over 1000 into 10 to the power minus 5. It will give us 1 into 10 to the power minus 1 ampere. So these are the values in various situations. This is 0.01 ampere. This is 0.001 ampere. This is 0.05 ampere. And this is 0.1 ampere. In question 9, we have a coil of inductance 5 millihenry and negligible resistance is connected to oscillator of previous problem. We need to find peak currents in circuits for various omega. So this is the ninth one. L is 5 millihenry, that is 5 into 10 to the power minus 3 Henry. A part, omega equal to 100 per second. So we know that XL is omega L, 100 into 5 into 10 to the power minus 3.5 ohms. So I will be V0 over XL, 10 over 0.5, 20 ampere. Omega 500 per second. XL will be 500 into 5 into 10 to the power minus 3. So it will be 2.5 ohms. So current will be 10 over 2.5, 4 ampere. Then omega becomes 1000 per second. So XL will be omega L will be 1000 into 5 over 1000. So it will be 5 ohms. So I naught will be V naught. Or let's directly put the values. (10 over 5), 2 ampere. So these are the various values of current that we obtained. 2 ampere, 4 ampere, 20 ampere. In question 10, we have a coil which is having some resistance 10 ohms and inductance of 0.4 Henry. It is connected to AC source. We need to find average power consumed in the circuit. So the 10th one, what do we have? R is 10 ohms, L is 0.4 Henry, voltage is 6.5 volt, frequency is 30 over pi hertz. Now we can find Z by this formula, R square plus omega L, that is 2 pi f into L, and power is Vrms into Irms into cos phi. So 6.5 by Z and cos phi can be R by Z. R is 10, Z square, that is root R square plus 2 pi F L whole square and its square. So root will get cancelled out. So ultimately 6.5, 6.5, 10 over R square, this is 10 square plus 2 pi, F is 30 over pi, L is 0.4 whole square. So after simplification 6.6, 6.5, 6.5, 10 over 100 plus 576. So from here power will be equal to 0.625 watt. So this will be our power. It can also be written like 5 by 8 watt. In question 11, a resistor of some resistance is connected to AC source. Voltage is given. We need to find energy dissipated as heat during 0 to 1 second, 0 to 1 millisecond. So the 11th one, we know that heat is V square over R into T. V naught is 12 volt. Omega is 250 pi. R is 100 ohms. So heat equal to 0 to H dH. So let's integrate this. So let's put all the constant values outside. V square is 144, 12 into 12. R is 100, sin square omega t dt. So once you simplify this, you will obtain 1.44, and this sin square omega t can be cos 2 omega t, 1 minus cos 2 omega t over 2 dt. Now after integration, we can write it like this: 0 to 10 to the power minus 3 dt minus 0 to 10 to the power minus 3 cos 2 omega t dt. So let's integrate 0.72. It will be 10 to the power, it will be t 0 to 10 to the power minus 3 minus sin 2 omega t over 2 omega from 0 to 10 to the power minus 3. So 0.72, upper limit minus lower limit, upper limit minus lower limit will be done here, and we will obtain 1 over 500 pi in this part. So ultimately pi minus 2, 1000 pi into 0.72. So after simplification 0.002614. So approximately heat will be equal to 2.61 into 10 to the power minus 4 joules. This much heat will be there.